Okay. Shoot, there we go. All right. Okay, got some power issues, so I'm kind of sticking myself to the desk here. So here's the notes for the day. Okay, so you have this in front of you, correct? Right? Yes, 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 everybody. Note sheet. Yes. Input, say it. Output. I'm gonna have to write this. I did have this on the board, but I'm gonna put it on this sheet here. You forgot your group again? Okay. All right. All right. So here's what we have first here. Remember, I told you, not told you, but on Friday, we said that logarithms are inverses of exponential. So this first graph actually is the exponential, and it does look like it is y equals 2 to the x. Because when I plug in 1, what's 2 to the first power, everyone? What's 2 to the first power? 2. And then what's 2 to the second power? 4. So I did kind of want to show that there, that we do have this going on. And then 2 to the negative first power is a half. All right, so that's why for an exponential, we have a horizontal asymptote at y equals 0. That's what this side represents. There is no x-intercept, none, or what they sometimes say is NA. And then the y-intercept is 0, comma 1. And then it is increasing forever. So this would be maybe like, what's the interval that it's increasing? It's increasing from negative infinity to infinity, because honestly, that's what the domain is. The domain of this, and actually both of these, is all real numbers. Okay, so this one is increasing. So this is the y equals 2 to the x. I don't know. They kind of put this all together here. Maybe I'll switch colors on this one and trace over it in green, because this one actually is literally y equals 1/2 raised to the x. I know that because, first of all, when I zoom in on these coordinates, 1/2 to the 0 power 0. What? I do love math. Did anyone just see that happen out of nowhere? Oh man, it's just the crazy things going on in this computer. And then when I take this to the first power, 1/2 to the first power is a half. 1/2 to the negative first, that's the flipping. That's how I get this to be -2. And it does look like it's right at -2 there. So, and then 1/2 to the negative second is 2 to the second, flip. All right, negative exponent rule. Okay, so this one is decreasing. So the y equals 1/2 raised to the x. That one is a decreasing function from negative infinity to infinity. So I'll kind of trace this in green. So it just correlates how they structured their notes. We still have this asymptote, so those are shared between these two. All right, hopefully this thing behaves. So the asymptote's still that. The domain is still all real numbers for the green one. So I'll circle this in green, what's true between all of them. The only thing that's different is one's decreasing, one's increasing. All right. The range, though, is the same for both of them. The range is from 0, not including it, to infinity for both exponentials. Okay, so that's what we have there. You see a double Samulus there. Okay, but I don't know. It's kind of weird to write this way with this angle showing the presentation here. We don't really need it. Just look at my Star Wars poster right there. Okay, when I say inverse, you say, what do you say? Switch X and Y. Now I can't shrink the screen for some reason. So a logarithmic graph, we're actually going to put this right here, and we're going to do this one in red, but this is y equals, well, okay, let's do the whole thing in reference to what we did Friday. So we switched X and Y. So now this is X equals 2 to the Y. And then insert the word log. This is how I just want you to do it. There's another way, but it's whatever you do to one side, I do to the other. When I throw the word log in here, the base becomes 2, x becomes here, the argument, and then y, the exponent, gets isolated by itself. So the whole point of a logarithm, getting the exponent isolated. And then honestly, well, I could take all these points and flip them. I guess I'm going to keep this in red. So 0, 1 now becomes 1, 0. but really it's going to be because we're gonna plug in points. All right, and these are the key ones. And I think I'll write this in general format like I did in first hour. Like for instance, well, what happens when I plug in 0? What's log base 2 of 0? Can I raise 2 to a power and get 0 as an answer? Is that possible? No. So that's your undefined value. That is where the asymptote is. So we're going to locate that point for every graph today. Where do I get 0 on that inside? Then that's where my asymptote is, because this cannot happen. All right. But then what we want to do is analyze this point. And I'm doing this on purpose that I'm skipping one. So skip one. Okay, so when I plug in 2, this is why I said this worksheet right here. This is the key input output worksheet, doing these logarithms in your head. 2 to what power equals 1? What's the answer to that? 3, 2, 1, go? 0. And if we can't answer that, we're severely and totally what? Behind. We are. Or if I put a 2 in for x, log base 2 of 2, 2 to what power equals 2? 3, 2, 1, go? 1. And then the next one, I'm going to skip 3. I want numbers that work nice with base 2. So what's log base 2 of 4? Or 2 to what power equals 4? 2. All right. And then I do have to keep these around. Now, one thing I did skip was 1/2. Why did I put a half in there? Or why do I want a half? Because that's our negative exponent rule. All right. Flipping. So 2 to what power equals a half? What's the answer to that? We just said it. 3, 2, 1, go. -1. All of these evaluations now, you will have to do this on a graph. Anyone that I've said input, say it. Are you just saying it or are you doing it? This is graphing 101, and you're going to have to graph without a graphing calculator. You're not just be able to copy a screen. You got to find some critical values, and it may be up to 5, no more than 5. It may be only 1 or 2 if you just know behaviors. So the x-intercept does exist. The y-intercept does not for an unshifted logarithm. The asymptote is not horizontal, it's vertical. This is this behavior. This is the 0 being undefined. 0 for x is undefined. That's the first boundary level. And then I already graphed 1, 0 right here. But then here's the symmetric point to -1, a half. It's half, -1. So it's that point. And then here's some other symmetric values. 2, 1, 1, 2. And then 4, 2. Did I go too far? 1, 2, 3, 4, 2. You can see these are stretched out a little bit more than up and down. That's why it looks a little distorted. But that's okay. All right. And then here's the y equals x line. Sha-na-na-na. Say it. Na-na-na-na-na. Some people smattering of sha-na-na-na-na-na-na-na-na. Okay. Symmetry sound. Okay. So that's what we can expect for a logarithm. All right. And it is increasing. So this one is increasing. The log base 2 of x is still increasing. Log base 2 of x. And it increases from, wrong. We have a domain issue. So this is kind of connected to the domain issue. This graph only starts just after 0 because we have a boundary on the on that graph there. So the domain is, I might as well write that, 0 to infinity, but now the range is all real numbers. When I say inverse, you say switch x and y. Look at these. These are switched, all right? And we've already talked about that, but I don't want that circle interrupting my notes. I have no idea what just happened there. Hit the wrong thing. I'm at the back button. Hopefully it still works. Okay. All right, so domain and range exchange there. Love you. Okay, and then we're going to do not the full inverse here, but this one, this is y equals log base half of x. Okay, so the inverse of that one is truly that. And then what you end up getting is those invertible points. I am going to put this here, and it actually is decreasing, so we will see that here in a minute. Notice this is decreasing, and then so is its inverse. But I can plug in points. I can. But the ones you have to plug in is you got to think like fractionally. First of all, still 0. 1/2 to what power is 0? What's the answer to that? Not possible. That's why we have a vertical asymptote. All right. And then we got some other things like I really got to do like let's say like well I could do 1. All right, then I got to get a little weird on this other one. What's anything to the 0 power? What's anything to the 0 power? 1. All right, so if I get here, so 1/2 to the 0 power equals 1. That's why we still have that 1 comma 0. That's what's going to be kind of tough, but it is true. This is what you have to, locate here. So now, maybe it's this one. This is pretty easy. If I put a half in there, what's 1/2 to what power equals a half? So I found a good point here. 1/2 to what power equals a half? Oh my gosh! All right, fingers hitting so many things. So this is 1. So 1/2 comma 1. This is kind of messed up here, but that's related to our other point over there that we had there, over on the other side there. And then maybe 2. Now this is the negative exponent rule. 1/2 to the negative first is 2. So that's that flippage there. But again, the inputs are changing or flipping with the outputs. 2 comma negative 1. And then another one would be 4. 1/2 to the negative second flips that to be 4 as an output value. So 1, 2, 3, 4 comma negative 2. All right, so you're going to play the input output game. I would like at least maybe 3 points. We'll see with ln how I'm going to change that because it's kind of tough with log base e. But 3 points minimum. And the 3, well, it's actually really 4, but it's really these are the key. Where's the asymptote? Where does the 1, 0 point end up? And then maybe 1 or 2 more points before and after that. All right, to get those graphs. So this is actually decreasing, and it's decreasing from wrong 0 to infinity. That interval that we have here. One thing that they didn't do on this is limit notation for end behavior. And I don't really have a lot of space for that, so I'm going to save that for another one. All right. Okay, so I'm going to actually make up some, and I'm probably just going to use base 2.5 again. 2.5, 2 different things there. So I could go back and forth on this, but actually it looks like they kept the parent function as the base 2. So this is all y equals log base 2 of x. And then comparing just those are the 3 parent functions. What happens when I do these things? Okay, so one thing that could happen, a horizontal is log base 2, let's say y equals log base 2 of, and then let's say x plus 4. I believe that's the one they did on the video. And I'll leave that video there, but I'll have a complete video of my own. He does a little Desmos slider presentation showing some changes. It's okay. It's kind of why I wanted to take over and do this myself. But really, input, say it. What's the first number I'd put in the chart? And I'm actually going to do this. I'll put this in this sense because this is how I want you to think. What would be the first number I'd put in there? How do I get 0 on the inside? What do I have to plug in? -4. So -4 is the undies value. So that means at -4, 3, 4, we definitely have a vertical asymptote. Now I'll tell you why, sometimes in the past I've let students only plug in one more point because the next one I'd plug in is -3. But then I could show around above and below what happens. What's -3 plus 4, everyone? 3, 2, 1, go. 1. You will not have a graphing calculator when we're graphing these. You're going to have to do this. So what's -3 plus 4, everyone? 1. 2 to what power equals 1? What's the answer to that? 3, 2, 1, go. 0. There's your new x-intercept. So I could see that this is moved 4 left. All right, so that's why this is in the horizontal translation. format there. Okay, and then all these other points get moved 4 left, so it's still gonna be increasing. So I could do, how do I get 2 out of this? I'd have to plug in, -2 because -2 plus 4 is 2, log base 2 of 2 is 1. So at -2, I'd get 1, alright? And then that's really enough. You got the asymptote, and then the graph just looks like this. So what's not affected is the range. The range is the same, but the domain now changed because the asymptote changed. So you might want to note that. And then that's down here on the bottom. What transformations affect the domain and range? None affect the range. The domain is affected by a horizontal shift. We just saw it right here. Horizontal shift definitely affects the domain. Something else does. The range is all real numbers. That can't be changed. That can't be affected in any way, shape, or form. All right, and then real quick, y equals log base 2 of x, I don't know, plus 2. All that happens with our input outputs is they get added 2 to it. 2 gets added to it. I said that very poorly. All right, I would still plug in 0. Log base 2 of 0 is still undefined. Undefined plus 2. Actually, I should graph this in green just to show a difference on this. So this doesn't change. What does change is the very next thing. When I plug in 2 for x, let's skip to that one. Actually, no. I want to plug in 1, and we'll ignore the fractional thing. When I plug in 1, log base 2 of 1, that's 0, but 0 plus 2 is 2. So now I'm at 1 comma 2, and I'm going to zoom in on this now and make this look a little bit better. 1 comma 2, this point was shoved up 2. But really, it doesn't change too much more than that. I'll graph a couple other ones. Log base 2 of 2 is 1, but 1 plus 2 is 3. And I'll write that like that just so you can see it. So it's at 2 comma 1 2 3. That's weird. I kind of accidentally, I don't know if those really intersect there, but it doesn't really matter. One more I'll do is 4. Log base 2 of 4 is 2. 2 plus 2 is 4. So now I have 4 comma 4. 1 2 3 4 comma 1 2 3 4. All right, so the graph is shifted up, but then this behavior is exactly the same. It does approach that asymptote like that. So it's kind of hard without getting super specific points exactly what happens there. I could get more. I just got to get powers of, 2. Like I'd try to create 8. So another point I could come over here is plug in 4 for x. If I plugged in 4 for x, 4 plus 4 is 8. 2 to what power equals 8? What's the answer to that? 2 to what power equals 8? 3, 2, 1, go. 3, actually. 2 to the third. So when I plugged in 4 for x, I'd get 3 for y. That would be another possible point I could plug in. And I certainly could ask, f of questions, input-output questions. What is f of 4 in the first one? The answer should be 3 because 2 to the third equals 8. Very not tough questions, especially if you did this legitimately, because that's all we're actually doing is doing those evaluations. All right, but you got to do the homework. We all know that. Some do, some don't. And that's the world we live in, unfortunately. All right, horizontal and vertical dilation. So here's what a horizontal dilation would be. Log base 2 of negative x. All right. Well, I would like to approach this as input output. Still, I can't plug in 0, but now I cannot plug in 1. I can't plug in 1 because that is log base 2 of a negative number. You can't raise 2 to a power and get a negative, just like you can't take 2 to a power and get 0. So literally what you have to plug in is negatives. You have to cancel those negatives. So when I plug in -2, that becomes -2, which is 2. What's log base 2 of 2, everyone? 3, 2, 1, go. 1. I'm not going to wait for you. All right. And then when I plug in a -1, -1, -1, or -1's 1. 2 to what power equals 1? 0. So this is flipped. -2 comma 1. This should be enough. All right. And then that changes the domain for sure. So there's this graph. All right. And that's the red one. Okay. So the domain is actually affected by a horizontal dilation as well. I'm sorry. Horizontal. Oh, shoot. I screwed up. I'm a bum. And this belongs down here. I did a reflection. My bad, dogs. I'm going to keep the video as it is. I know you can't do that. You might want to do a quick relay, erase on that and move this down. I obviously did a reflection over the x-axis. I'm sorry, y-axis. All right, and that did affect the domain. The range is not affected. It's still all real numbers, forever up and down. Okay, I'll stick with reflections. That means I have to take this picture and slide it on down here. Ooh, let's try to make this happen. Nice. I think I got it. I know you don't have that option. My bad. All right, little mistake on a Monday. Okay, so sticking with this, I'll do a vertical reflection that shows up like this. Log base 2 of x, but a negative on the outside. Again, still input output. You still can't plug in 0. You still get undefined, but now you can plug in 1 and 2. All right. When we get to graphing with nicer bases, I am going to do 5 points. I just want to get these basic points figured out what's happening. All right. So back to 2, plugging in 2, log base 2 of 2 is 1, but then you get a negative slapped on it. All right. So we're instantly at 2 comma negative 1. This point is flipped over the x-axis. All right. This one is still at 1. Log base 2 of 1 is 0. Negative 0 is still 0. This does not flip. I should have squeezed a half in there. Log base 2 of a half is negative 1, but then it's negative. So this gives me 1 as an output value. 1/2 comma 1. All right. And then this is a little bit retro. I don't know what this is. Okay. Man, I've been getting some bogus phone calls lately. All right. And then the graph does this. So there's the reflection over the x-axis, the flip. Okay. And that's pretty easy there. All right. And then horizontal and vertical dilations are not like, don't happen too much, but we'll go ahead and write what this is. This would be log base 2 of 2x. This would be a horizontal, what is it? A horizontal stretch or shrink. You guys remember? Horizontal stretch or shrink. You get to pick one. 3, 2, 1, go. It's actually a shrink. Why? It's an inverse relationship. That's the one thing that we got to. And what does that mean? It gets pulled towards the y-axis. So still, I could plug in 0, and I could see this happening just with a couple points. Still, 0 is undefined, so I have no change on the asymptote there. This would be really hard in a small picture to show this new graph. Well, when I plug in 1, here it is. 1, 2 times 1's 2, and then log base 2 of 2 is 1. So we get it happening right away. And then when I plug in 2, 2 times 2 is 4, but log base 2 of 4 is 2 because 2 squared equals. So I get 1 comma 1. This point right here was pulled towards the y-axis. That's why we call that a shrink. All right. And then what do we have? 2 comma 4, 2 comma 1, 2, 3, 4. This point gets pulled all the way there, right? Oh, 2 comma 2. I knew that was wrong. That didn't seem right. 2 comma 2, which is this point, which was at 4 comma 2, but it's pulled towards the y-axis. You still get this basic shape though. So domain, range, nothing changed. The asymptote didn't change, just a little bit of shape. All right. And then the other thing would be like this: y equals, let's put a 2 on the outside, 2 log base 2 of x. And then we'll do this in green, even though I wrote it in red to start off with. Still 0 undies. So you still have this. But then what you have here is when I plug in 1, well, that still doesn't change. Log base 2 of 1, 2 to what power equals 1? 0. 0 times 2 is 2. So that's not a change. So we share a parent point here. But then right away when I plug in 2, log base 2 of 2 is 1, but then it's 1 times 2. 2 comma 2. But that's the only point these two graphs share. If I plugged in 4, log base 2 of 4 is 2, but 2 times 2 is 4. So that's at 4 comma 4. 1, 2, 3, 4. 1, 2, 3, 4. A little bit higher. Okay, so there's the pushing up away from the x-axis. That's why it's a vertical stretch. That doesn't affect the domain and range either. Very minute stuff going on here. All right. So we're at 9:09, and that's fine. What I did in the other hour was really graph these pretty well. We're going to ignore the calculator today. Don't kill it. Maybe start with that tomorrow, and then I'm going to do 5 here. So I'm going to do 3 more that kind of venture in continued notes, but then some of your homework just to get you an idea. And hopefully you can watch. Like I said, college. This is a lot of information, and we need to really stick with it. But really what we need to know is this, that this is related to just the log base 3 of x graph. And then we need to know the basics of the parents. When I plug in 1, I get 0. When I plug in 0, I get undefined. That's where this asymptote is for the parents. And it increases because the base is bigger than 1. I'm not going to input output on the parent. We should just know this. But when I plug in 3 for x, I get 1. So 3 comma 1 would be an output value. That's why those 2 points alone plus the asymptote give me enough to give a sketch, right? So that's the minimum we're going to be looking for. Remember this though, we do love questions about what does this do? So what does that negative out in front do to the parent? Give you a 50-50. Is it an x-axis or y-axis reflection? 3, 2, 1, go. It's an x-axis reflection. Negative out in front is an x-axis reflection. We do love these. Sometimes you just get the equation and they just ask you to name it. Name what happens. All right, what's the to do out in front? It's a vertical or horizontal, stretch or shrink. Which one is it? 3, 2, 1, go. Vertical and what? Stretch. So that is a vertical stretch by 2. Vert, stretch, STR is good enough, by 2. That's just naming the number, so we're locating where that number is. And then what's the last thing? What's the minus 2 do? 2 which way? And then who does that really affect? The asymptotes. Okay, so we're going to do a lot of stuff here, and then I'm going to write a lot of things for this. So I'm going to include our limits as we go to infinity or negative infinity. Actually, that's not correct what I just said on the second one. I'll show you what that means here in a minute. But we're still going to input, say it, output. And you got to make these things happen. I'm going to try to get 5 points. What I'm going to try to get is, where does it become 0 as an output? Where does it become a half? What's a half for? I'm sorry, not a half, a third. I had my last example. Why a third? 3 to what power equals a third? That's the question. 3 to what power equals a third? 3, 2, 1, go. -1. That's this sheet right here. We're legitimately doing our homework. These things build on each other. That's why the non-homework doers are failing miserably. And then I want the 3 points and then maybe the 9 point. Why? 3 to what power equals 9? 3 to what power equals 9? 2. But I need to create these values by inputting the correct things. So number 1, how do I get 0? What do I input for x? What do I input for x? What do I input for x right here to get this to be 0? One person said it, everyone say it. 2. That is the undefined value. Right off the bat, I'm going to the graph. I'm going right there. 1, 2, that is where my vertical asymptote is, the 0 of the logarithm. Why? You cannot evaluate log base 3 of 0. That doesn't work. I don't care anything else that's around it, the -2 on the multiplier or the -2 right left. Undefined is undefined. All right. Now, how do I get a third? This is tough. I'll do it. I got it. It's 2 1/3. It's really not that hard though, because 2 1/3 minus 2 is the third value. All right. I do like to see this so I can see the behavior to the asymptote a little bit. All right. And I do expect this. I'm going to circle this. What's log base 3 of a third then? What's the answer to that? What's log base 3 of a third? 3 to what power equals a third? 3, 2, 1, go. -1. But then I have to multiply it by -2. And what do I end up getting? 2. So 2 1/3. Here's 3, 2 1/3, comma 2. Okay, interesting. Look at that. I love math. I don't. Did this happen in this hour? Right already? This is crazy. I don't know why I'm getting the hearts. Okay. Anyway. All right. And then guess what I'm going to plug in next? 3. Actually, I skipped one. I'm a maroon. There is 5. I want 1, then 3, and then possibly 9. I want the 0 power thing. All right. So I skipped it. Oh my goodness. What am I doing? So how do I get 1? What do I plug in for X to get 1 on the inside? 3, 2, 1, go. 3, Mr. Samulus. What's 3 minus 2? 1. 3 to what power equals 1? Checking that phone. 0 times -2 is what? Teaching in America. Turn your back, you get stabbed. They just can't be away from those devices. And then how do I get 3? What do I plug in for X? What minus 2 equals 3? And then I could ask this as f of 5 question. Hey, what's f of 5? Just to see that you are inputting, outputting. All right, f of 5 is plugging 5 in the chart and getting the output value. What's 5 minus 2? 3. What's log base 3 of 3? 1. 1 times -2 is -2. Okay, I'm starting to see some shape here. I think I got it. 5 comma -2. I think I'm good. I think I see that this graph does this now because I know what the behaviors are supposed to look like. So there's that situation. So f of 5 equals -2. That's correlated with this. We love those kind of questions. We really do. And I think I'm going to force it with the other communists. I want this on my test, so everyone's got to do it. I'm going to fight for it, that we do these f of questions. All right, and then how do I get 9? Even though this goes off the charts, let's just play around. How do I get 9? What would I have to plug in for X? I heard someone say 11. Very simple. 11 minus 2 is 9. Log base 3 of 9 is 2. 2 times -2 is -4. So I could ask, what's f of 11? And then that's just in tune with the students that are doing the right thing. They understand how to input, output, and get these powers of 3 very nicely. Good values on the charts. Okay, so things that we can write now. Domain. Well, the domain was definitely affected by the right. Range, all real numbers. This is going to be an always for these. What other things? Asymptotes. Okay, we're going to get to the limits now, and the limits are review. So it's not like I have to teach this like this is brand new. Also, although some of us never got the limit questions right, and I don't know what to do about it. But we can only just keep repeating. There is no y-intercept, but there is an x-intercept. It can be found. Sometimes it can't. Depends on the shifting that we have here. And do the intercept as a coordinate. So it's 3, 0 is what we ended up having there. All right, the limit notations. There's 2 of them that we can do. First of all, the graph does have a domain that goes off to infinity. So we want to say what happens as this goes off into infinity. So I guess I could kind of highlight this. Since the domain goes off into infinity, I want to find out the behavior of y as we go off to infinity. So input, say it. 5, -2, 11, -4. Where are the y's going as I plug in bigger and bigger x's? 3, 2, 1, go. Negative infinity. I can't cover that anymore. Those that cannot get that, you're just going to keep getting these wrong the rest of the year. I don't know. I don't know how else these can be approached. My hands are tied. All right. But then the other one is it really has to do with this. The domain stops at 2. So that's where the graph does something unique as well. So we have had this before. This is not new. So how do I approach that asymptote? I approach it from the right. So it's a 2 with a big plus right here. That means 2 from the right. This is review. What that means. We've already asked this with rational functions with vertical asymptotes. We did. Okay. So we can't spend a lot of time on it. There is no time to spend on it. You either get it or you don't at this point. So as I plug in, well, look, this is when I plugged in 2 1/3, I got 2. What if I plugged in 2 1/9? This would be up here. What if I did 2, and I'm actually doing things that actually work nicely with powers of 3, if anyone's clicking with me. 2 1/27 is way up here. Where are these y's going as I'm getting smaller and smaller and closer to, 2 for x? Where's that going? It's going to positive infinity. So that's if I plugged in 2 1/9, 2 1/27, which 1/27 would be 3 to the negative third. Blah, 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 blah. That's getting more in depth with it. Okay, so these are all the things that you're going to be expected to know for a logarithm. All right, but input, output, at least 3 points. The asymptote, where does the 1 0 point go, and maybe one more. The other teachers are making you do 5. So in the test, I'm probably going to have to see 5 on the chart. All right, here's a problem with this one. This is always an issue. And I really don't think we can get 5 values with ln. Because what is ln? Log base what? E. What is E? E is 2.718. All you need to know is E is greater than 1. So its parent increases. We still have the 1 0 point because E to the 0 is still 1. But then the next point is 2.718 comma 1. And I'm not going to expect you to know that, but it is true because E to the first power is 2.718. Really, all you need to know is we still have this asymptote here, and it does increase like this. So this is almost identical to the y equals log base 2 of x. It's just log base 2.718 of x. All right, and I want you to really understand that. But for all intents and purposes, for ln, I'm probably only going to do about 3 points. And the first one is what creates this to be 0? What would I plug in for x? 4. By the way, I was supposed to do this. Sorry. Let's name the transformations. First thing, though, is I have to pull out a negative on the inside and turn this into x minus 4. And then plus 2. And then I ask, what does this do? Is that an x-axis or a y-axis reflection? 3, 2, 1, go. It's a y for those that answered. Nicely done. It's a y-axis reflection. We love these. Remember, we might have to list them. Okay. The other teachers will probably say, we need one where they have to name the transformations. What's the 4 do? 4 which direction now? You wouldn't see it in the original. Okay, but what does that 4 do now? Which way does it go? To the what? Right or left? 3, 2, 1, go. It's actually right. You'll see this when we input output. And then what's the 2 do, which is easy? Up 2. So we have to know how to pull out that negative. So A, we could see it as a y-axis reflection, but B, it changes what you might have thought, which direction it's moving. It's actually moving right 4. And we're going to see it right now. We are. Because look at the parent. Parent has x equals 0 as an asymptote. This one, it's going to be x equals 4. So it's undefined here. One other nice value we can plug in is 3. This is still evaluatable, but then I'll tell you why for an ln graph. I'll ask the others what they expect you to do. I don't want you to do much more than this. But what's 4 minus 3? What's 4 minus 3? 1, what's ln of 1? E to what power equals 1? 0, what's 0 plus 2? That's where 1, 0 ended up. So now I can actually do a sketch right now. Well, I got to do a little bit more. 1, 2, 3, 4, and then I have that vertical asymptote. And then it was supposed to be 5, 0, but it got flipped over to 3, 0, but then moved up 2. So that's what I want you to understand about what happened comparative to the other graph. Without the flipping over the y-axis, I would have been right here because that's where the 1, 0 gets shifted to, but it got flipped and then moved up 2. Right now, if you can imagine what it looks like after that, flipping over the y-axis, it does this now, this behavior. And that's why ln is not as nice because you can't get your input-output values very well. It's hard to get 2.718 perfectly. So I'm going to ask the others what they expect on an ln graph. I think you should just know that it's increasing. When you make the changes to it, make the changes appropriately. All right. It's really hard to get 5 points. And then I guess I will do domain and range. I'll squeeze it in here. The domain is definitely affected majorly on the flip over all the way up to 4. So it's negative infinity to 4. And we could see that in the picture. The range, never affected. Asymptotes, that is x equals 4. The x-intercept is hard to find, all right? We'd actually have to plug in 0 for y and then solve. And we haven't solved enough yet to know how to do that. So sometimes we won't ask you what the x-intercept is. And then the limits, I'm going to go ahead and do it, even though it's going to leak into this calculator question. Now for this one, it's when x is negative infinity. These are the values that work for x. So as I plug in negative infinity for x, here's where y goes. Where's y going, everyone? Positive infinity. And then the other limit is as x gets closer to that asymptote, but this time from the left side. That's from the negative side of 4, or something smaller than 4, like 3.9999. And we actually did that. I think it was the day I was missing when I had to go to a meeting that I didn't really want to go to. I had to go to a meeting, so you had to watch a video about behavior around vertical asymptotes. True story. Okay, I said I was going to do one more, and you guys could probably do this one, just naming the transformations and see how they affect the parent graph. So you're going to have 3 graphs on here, all right, and how are they different than the parent? I like that question. Remember, for ln, maybe just 1 coordinate might be fine, but for this one, I am going to do the typical 5. All right, so here we go. I'm going to do number 5. What I want you to kind of do for this. All right. So the first one is the undefined value. What makes this undefined? We're not going to name the transformations either. We don't have enough time. So what would I plug in for x to make this undefined? -3. And then understand -4, -5, -6. No way. You can't take 2 to a power and get a negative output. So this is the beginning of the problem for the domain. All right. And then we go forward from here in this case. So that's undies. And then obviously it's, you know what? I'm going to skip one. I'm going to do -2 here. That's easy. Okay, now you have to input, say it. And then you got to really calm down and get your evaluations done here. You have to focus on this first for PEMDAS. So -2 plus 3 is 1. 2 to what power equals 1? 3, 2, 1, go. 0 times -2. Now it's PEMDAS. What's 0 times -2? 0 minus 6. -6. So really what I do before I answer any of these questions, I actually graph it first. I literally, if I was someone that had to do this question, I'd graph it. Then I'd go back and name domain and range, but I know what the domain and range is already. All right, so -2 comma -6, 2, 3, 4, 5, 6. That 6 was majorly moved down. All right, so that's why this is way down here. So I at least need to see that coordinate. This may be arbitrary, but it is actually not that bad. It's -2 1/3. Why did I choose that? What's -2 1/3 plus 3? All right. Actually, I'm wrong. It's -2 2/3. I made that mistake last hour. Shucks. It's -2 2/3 plus 3. Because what does that leave me with when I add -2 2/3 to 3? 1/3. I'm sorry. I'm an idiot. I have 3 in my head from the last question. I did not do this wrong the last time. I thought the base was 3. I screwed up. Okay, so -2 plus 1, 2 to the, yeah, okay, so we're still good on that. -2 1/2. My bad, dogs, roof. What's -2 1/2 plus 3? 1/2. 2 to what power equals a half? -1. Now what's -1 times -2? 2. What's 2 minus 6? Finally got my ducks in a row here, as they like to say. All right, I know the bell's about to ring, so it's -2 1/2 comma -4. Basically, what you're going to get for this is this graph if I kept going with the input outputs. So we could answer all the other questions here. All right, as the bell's about to ring, I'll finish this off as we leave. So it's x equals -3. The domain is that affected asymptote change, and then the range is never affected. Notice we don't ask the x-intercept because it's a really tough decimal. So I can't really name that right now. We don't have the ability to do that. We have to wait till solving. But now we're back to going off to infinity. And when I go off to infinity, that's where y goes. And then when I go off to approaching the asymptote, and in this case, we're approaching the asymptote from the right. So the asymptote's at -3, and I'm just right of that, which is a positive number to the right of that. That's where the graph goes, infinity. Okay, so graphing 101, they're walking out the door. I guess I could input, output a couple more just for giggles, just to finish the video. So -2. -1 does work nicely because -1 plus 3 is 2. Log base 2 of 2 is 1. 1 times -2 is -2. Minus 6 is -8. So we could see this decreasing behavior as x goes to infinity. Another nice one would be 1. See ya. 1. 1 plus 3 is 4. Log base 2 of 4 is 2. 2 squared is 4. 2 times -2 is -4. Minus 6 is -10. Okay, so we can see now that the y's are starting to take off there. Okay, I think that's good enough. And then, just like looking at 1 comma -10, that's just proof that this keeps going down. All right. Graphing logs 101. Input, say it. All right. Oh, I missed.